A very good afternoon to all of you. See, in the yesterday class, I shared a slide that compiler versus interpreter. I think up to this slide, you are all are clear about the topics what I delivered in the yesterday class. And again, I'm repeating the same topic of language processing phases as I already delivered in the last class. Again, I'm repeating the same topic in this class. And because in this class, we are again, after knowing the phases of process of language system, we also know what and what the tools that we're having and how the internal functionality of the tools are going to be performed. So for that, again, I'm repeating the same topic, that is in language processing phases. After knowing in detail about the phases with an example, by taking an high level language like an C, then we can know what and what type of tools that we're having in the compilers and what the internal functionality of the tools here. So once all of you see the slide that I shared here, this is nothing but the language processing system, where the language processing system mainly consisting of four phases. Mainly consisting of four phases. And before going to know about the internal functionality of the language processing system by knowing about each and every phase, first we have to know what is a language processing system. What is an language processing system? And everyone is very much familiar with the computers and everyone is very much familiar with the words software and hardware. So the computer system is made of both the hardware and the software, both hardware and software. And here uh, again we are familiar with the binary code. Why? Because we know what the binary code consisting of, what the series of binary code consisting of. But the binary code consisting of only zeros and ones, series of zeros and ones. If you see any code like with zeros and ones, then we can easily understand that it is a binary code, but we don't know what the output of that code is. We can't recognize that what the output of the code is, but we can easily understand because the series, that code consisting of zeros and ones, where it is in the form of a series format. So we can easily understand that this is an binary language code. So for an human, it is very harder to understand the binary code. And what type of a language that the human can easily understand? Human readable languages. Where here the high level programming languages are, all the high level programming languages are easily understand by the human or the user who is going to write the codes, who are the writers of the codes, and who are implementing the compilers, who are implementing the compilers. So for that, the hardware understands a language. Which language the hardware understands? The language which can't understand by the humans. That language is nothing but an binary language. So we write programs in a high level language which is easier for us to understand and remember. High level programming languages are written for doing the compilations, and those are all very understandable languages and very, we can easily remember those languages. So after writing the programs in a high level language, then what is the process, what is the language processing system is, how the language processing system is defined is, and after writing the programs in a high level language, these programs are then fed into a series of tools. See, the slide that I shared to you, where the slide consisting of a series of tools, each and every phase is an individual tool here. So these programs are then, so these programs are then fed into a series of tools. And also the most important thing, we need an OS component here. Without the OS, we can't do anything. So an OS components to get the desired code, that can be used by the machine. So this is nothing but the definition of what the language processing system is. Definition of what the language processing system is. And here now we're going to explain the structure with an example. Here I am taking an example as an high level programming language where it is a source program that I am considering here C language. I am taking the program C program here. The high level language is converted into binary level language in various phases. And see here, and after I am giving the input as a source program, whereas my input in the form of an high level language, and here I'm taking that as an C language program, and I'm giving that input to the preprocessor. What the preprocessor is a tool here. Preprocessor is a type of an tool here. What the preprocessor is going to be performed, and what type of an implementation by using the preprocessor tool we're doing. Generally, the preprocessor is considered as an part of an compiler. Preprocessor is considered as an part of an compiler. Again, is a tool that produces the input for the compilers. And see here, in the structure, we're having red mark arrow representations. What the red mark arrow representations is, initially the red mark arrow representation is taking an input in the form of an source program, and after performing the pre-processing techniques, then then the preprocessor is generating some output, make it as some output. Then after, I will explain what that some output is. Then that some output is taking as an input to the compiler. We are not again taking the source program directly. We are not taking the source program to the compiler. What we are taking here, whatever the output we are getting from the preprocessor, that output is taking as an input to the compiler. See, all of you see the slide, then you can easily understand what I am saying. Then after performing the compilation by using the compiler tool, we are getting some output. That output is again taking as an input to the another tool like an assembler. And after performing the assembler, then we will getting an output. We are getting some output. What that some output, I will explain in further. Some output, and that some output is taking as an input to the linker or loader. And finally, what we are getting, finally see the arrow representation. There we define the target machine code. That is the target intermediate object code that we are expecting to generate as an output of this given input source program. This is the way that we are applying the pre-processing technique. Here I applied the pre-processing technique. After applying the pre-processing technique, how we're going to define the pre-processing as, pre-processing is nothing but an taking an output of previous phase as an input to the current phase and performing the operations and then generating an output. And again, that output is taking as an input to the other phase and performing some operations and generating an output. And finally, after the completion of all the four phases, all the four phases that are included in this system. One is a preprocessor, compiler, assembler, linker or loader. And after completion, after performing the operations of the linker or loader, then finally we are getting an output in the form of object code. This is nothing but a definition of the compiler that we already learned in the last classes. What we learned in the last class? Compiler is nothing but a translator where we're translating from one language to the another language. Here we done the language processing system. We done the language processing system by using some phases, by implementing some phases. Here I gave the input in the form of an high level language, and finally that high level language is translated into an machine level language where it is a target machine code. Here it is a simple basic definition of the compiler, and whatever we learned in the structure of the compiler, here we're seeing that structure in the form of an processing system, language processing system. And now we all know what the compiler is, we all know what the interpreter is, and we all know what the assembler is. See here, assembler is also from the family of the translator, because assembler also translates from one language to the another language. Here we're having three types of translators. Up to now we learned one is an compiler, another one is an interpreter, and the next one is an assembler. These are the three types of translators we learned up to now. And assembler is also a type of a translator. And all of you make a note that by using the compilers, we are not directly translating the high level to the machine level language. What we are going to translate high level to low level. Low level in the sense here we need to consider the assembly language. And by using the assembler as a tool, and again we're translating or we're converting the assembly language into machine level language. See, from the preprocessor and at the end of the linker or loader, in between we are using two types of translators, and we have to know how the performance of each and every translator is. Make a note that difference between the translators that we're performing in this language processing system. In the compiler, we're translating high level to assembly level. In the assembler, we're translating assembly to machine level. Make a note that by using the compilers, we're translating from high level to the assembly level. By using the assemblers, we're translating assembly level language to the machine level language. This is the most important point you all should note down. And from the preprocessor and getting at the end of the object code, in between we are using two types of translators. One is a compiler and the another one is an assembler. And let us first understand how a program using a C compiler is executed on a host machine. See, I'm briefly explaining here with an C program. I'm taking a C program as an example. User writes a program in C language where it is an high level language, and then after pre-processing, after performing the pre-processing, it is modified into some source program. It is modified into some source program. Nothing we are doing in a pre-processing. Nothing we are doing in a pre-processing, because always the preprocessors deals with macro processings, or otherwise we can also take some like file inclusions or any type of an file extensions and so on and so on. Just where the the source program is modified, the output of the preprocessor is a modified source program. Nothing we are implementing in the preprocessing there itself. Nothing we are translating in a preprocessors by using the preprocessors. Just whatever the input we are giving as a source program, that it was taken by the preprocessor and it was modified, and it can be defined as an output of the preprocessor, and now that output is giving to the compiler. Now that output is giving to the compiler as an input. All of you once see the slide, then you can easily understand what I am saying. And now the C compiler compiles the program and translates it into assembly level language, where assembly level language is nothing but a low level language. And then an assembler that translates the assembly program into machine code, where machine code is nothing but an object code. Machine code is nothing but an object code. And then this object code is given to the linkers or the loaders. What the linker tool task is to be, what the loader tool task is to be. The linker tool is used to link all the parts of the program together for execution. That we can call as an executable machine code. That we can call it as an executable machine code. Again, I'm repeating about the linker. Linker is a tool. We can use it as a tool. This tool is used to link all the parts of the program together for the execution. And what the loader will do, what the task of the loader is, always the loader's task is to loading of all the parts, all the files, and loading them into the memory. And then finally the program is going to be executed. This is the process of executing an program from high level language to the machine level language. This what we are calling it as an language processing phases, language processing system, from the source to the machine code. And here we are having 4 tools. One is in preprocessor, compiler, assembler, linker or loader. And finally, we are getting an output in the form of an target machine code. And then before diving straight into the concepts of the compilers, we should understand a few other tools that work closely with the compilers. And what the tools that are working closely to the compilers means, the first tool, make a note all of you. The first tool is a preprocessor tool. The second tool is an interpreter tool. The third one is an assembler. And the fourth one is a linker. And the fifth one is a loader. And other more tools we are having, that those are cross compilers and source to source compilers. Cross compilers, for the tool like and cross compilers, we're having a concept in our unit. So there itself we can in detail learn about the cross compilers. But source to source compilers, we need to know what the source to source compilers is. First, I'm starting with the tool like an source to source compiler tool. What is a source to source compiler tool? What the task that the tool is going to be performed? For example, I'm having two programming languages. One programming language I'm considering as an example high level language, and the another programming language is an machine level language. See, by using the tool like an source to source compiler tool, what will happen is a compiler that takes the source code of one program. Make a note that compiler take a source code of one program, one programming language, and it translate it into the source code of another programming language. That is nothing but an source to source compiler. So that is nothing but a source to source compiler tool. Again, I'm repeating what the source to source compiler tool is. A compiler that takes the source code of one programming language and translates it into the source code of another programming language. So this is nothing but a source to source compiler. And the other tool is an taking as an interpreter is another tool. I already explained about what the preprocessor tool is, and now I'm explaining about the interpreter tool. We all know interpreter is just like an compiler. Interpreter is also a translator and also is just like an compiler. And here what we are doing, we are translating high level language to the low level machine language. High level language to low level machine language. And by seeing the comparison between the compiler and interpreter, we can easily understand what the task that the interpreter will perform and what the task that the compiler will perform, and what we are going to do in the compilation process and what we are going to do in the interpretation process. And for that, an interpreter reads a statement from the input and converts it into an intermediate code, executes it, and then takes the next statement in sequence. And this is nothing but a basic definition of the interpreter, how the interpretation is going to be done. How the interpretation is going to be done. As we all know, the definition of the interpreter is line by line interpretation is going to be done in an interpreters. While coming to the compilers, entire program is at a time, entire program is going to be compiled there itself. At a time, entire program is going to be compiled. So that is the major difference between the compiler and the interpretation. You all should make a note of this, the basic definition of what the compiler and what the interpreter, and what is the main important differentiation between the compiler and the interpreter. And then if any error occurs, for example, when I'm doing the compilation I'm performing for the entire program at a time. Then after compiling the program at a time, overall program at a time, then I can know what the errors are in my program. Then I can know by warnings of the errors. But while coming to the interpreters, how we can know about the errors, how we can encounter the errors?
మేడం ఈ సెక్షన్ 2 స్టూడెంట్స్ ఇందులో జాయిన్ అయిపోయారు, కొద్దిగా వాళ్ళు వెళ్ళమని చెప్పండి కొద్దిగా. హలో మేడం.
Yes sir.
సెక్షన్ 2 స్టూడెంట్స్ మన సెక్షన్ 1 లో జాయిన్ అయిపోయారు, వాళ్ళని వాళ్ళ క్లాస్లోకి వెళ్ళమని చెప్తారన్న.
All the section 2 students, please don't participate here. This is not your session. Today our session was already completed. You all please section 2 students, you yourself, and leave the session. Yeah, now we're going to continue our topic. Interpreter, I'm talking about an interpreter. I'm talking about an interpreter, and if an error occurs, an interpreter stops execution and reports it. Line by line, error encounter can be done in an interpretation. But while coming to the compiler, overall program at a time, when we're compiling the overall program, entire program at a time, then we can encounter the errors. That is the major difference between the compiler and the interpretation. And the next one here, we're having the another tool, that is an assembler. Assembler. What we are doing in an assembler, what the task of the tool is, again, the assembler is also a translator. It also comes under the family of the translator family. And here what we are doing, we're converting or translating assembly program, language program into machine code. You all should make a note that what the compiler definition is, what the assembler definition is, what the interpreter definition is. What is the difference between the compiler and the interpreter? Main differences between the compiler and the interpreter. And from which language to which language we are doing translations by using these tools. These are all you should make a note of these. Then the output of an assembler is called an object files. From the assembler, see here, after performing the assembler, there I am getting an relocatable machine code, where relocatable machine code is nothing but an object file. That is an output that I am generating by performing the assembler tool, and which contains what the machine code contains, what the relocatable machine code contains, or what the object file contains a combination of machine instructions as well as the data required to place these instructions in a memory. Data required to place these instructions in a memory. And next tool is about an linker. These two are the most important tools here, linker and loader. Without these two tools, we can't execute the program. We can't execute the object code. Then what the linker is a computer program. And what the task of the linker is, it links and merges various object files. See here, uh, library files or relocatable object files, or all these files are linking or merging to various object files together in order to make an execution file. Finally, we need an executable output. That executable output should be in an executable file. The major task of this linker is, what the major task of this linker is, it always search for what it is going to be search. A linker is to search. Make a note, a linker is to search and locate the referenced modules in a program. And this is the again most important tool, that is an linker is also a most important tool that plays a vital role in the language processing system. And the next tool, that is loader. And we all know about an operating system. Everyone knows what the definition of the operating system is. And these loaders are the parts of the operating systems. Make a note, loaders are the part of the operating systems. And what is the responsibility of the loader is, wow, by using this tool like an loader, what the responsibility of the loader is, this loader is responsible for loading executable files into memory and execute them. See there is an arrow representation for the memory. From after getting the object files, where it is going, it is storing in the, it is placed, all the object code whatever we are executing, that is placed in the memory. So again I'm repeating that the loaders are responsible for loading executable files into memory and execute them. And here, by using the loaders, as we already learned in the last classes, that in the slide of compilers, there I defined two constraints. One is in time and another one is in space. Space in the sense size. How we're going to calculate the space? How we're going to calculate the size? So by using these loaders, it calculates the size of a program. That means by depending upon the instructions and the data, and create some memory space for it. So finally what it will do, after knowing the size of the program and after creating some memory space for it, then finally it initializes various registers to initiate the execution. This is the description of each and every tool. This is the description of each and every tool. See, up to now I explained about 5 or 6 tools. One is a preprocessor, another one is an interpreter, next one is an assembler, then linker, then loader, then source to source compilers. Source to source compilers. The session is going to be closed. Still, some of them are still admitting in the session. What we can do? Yeah, this is the overall brief description about language processing system. In the next class, we are going to learn about the parts of compilers. Parts of compilers. There we are having 2 parts of compilers, and what the parts of compilers are, and the structure of the parts of compilers, and then we are going to learn about various phases of the compilers. And up to this, I think you all understand the language processing phases and also the tools that are closer to the compilers. Working tools. Closely working tools with the compilers are what I explained up to now. Those are all comes under the closely working tools of the compilers, and these are the 4 phases of the language processing system. 4 most important phases are preprocessor, compiler, assembler, linker or loader. In this way, we can describe how the processing can be done, processing can be carried out in the language processing system. And this is the topic for this class, that is language processing system, which was already explained. If you have any doubts, you can message in the chat box, and the session is going to be closed now. And for the tomorrow's class, I'm going to deliver about the parts of the compilation. Make a note, parts of compilers. Parts of compilers. And yesterday class and today class is about the introduction of language processing and language processing phases. Introduction of language processing and phases of language processing system. And in detail explanation with an neat structure. That's it.